Hey everyone! Today we're going to be looking at the proof of the finite geometric series formula. Let's say you want to sum up the geometric series A plus A times K plus A times K squared, so on, to A times K to the M. We don't know what this is in terms of A, K, and M, so let's give the whole sum a variable name. Let's call it S. What we're going to do now is we're going to multiply both sides of S by K. So K times A plus AK plus AK squared, so on, until AK to the M. And that will be equal to K times S. Distributing the left side, we get Ka, or A times K, plus K times AK, or AK squared, plus K times AK squared, or AK cubed, so on, until we get K times AK to the M, which is AK to the M plus 1, and that is still equal to K times S. Notice now, though, that the left-hand side of this equation is almost identical to the left-hand side of our original equation, right? AK appears in both of them, AK squared is in both of them, AK cubed is in both of them, even though it's not shown in the first line, all the way up to AKM being in both of them. So this means if we subtract equation 1 from equation 3, I'm gonna frame this subtraction by rewriting both equations down here. AK squared, so on, to AK plus 1. We're subtracting out A, AK, and so on, to AK to the M. And on the right side, subtracting from KS, just S by itself. If we do this, all of these middle terms annihilate each other, right? They all drop out of this final equation. And what we're left with is AK to the M plus 1, left over from the first equation, minus A, left over from the second equation, is equal to K times S minus S. I'm now going to factor both sides. On the left side, I'm going to factor out A, and that will give me A times K to the M plus 1 minus 1. And on the right side, I'm going to factor out S, and that's going to give me K minus 1 times S. And finally, I'm going to divide both sides by K minus 1. And that's going to give me A times K to the M plus 1 minus 1 all over K minus 1 is equal to S, which, recall, we defined to be equal to this geometric series sum that we wanted to find at the beginning. So that means that this sums up to the same thing that S does. A times K, Kn plus 1, minus 1 all over K minus 1. And there it is, the geometric series formula. Hope you guys found this proof as clever as I did when I first saw it, and thank you all for watching.